स्टार्ट करें। Okay, please. Good morning. Okay, so I am Dr. Satish Goel, and we will discuss today the lesson 3. Okay, I would assume that you have already done the first two lessons, which is about the basics of statistics. Okay, measures of central tendency, and then the measures of variability. Okay, so assuming that we have to start with the correlation. Okay, and in syllabus it is the unit 2 basically, correlation and regression. Okay, so here we have two chapters with respect to your syllabus. If you see the syllabus, in syllabus we have unit 2, the correlation and regression. Okay, so better no talking please. This is also live session please. So unit 2 have basically two lessons in your material. Okay, so first is the lesson 3. So in lesson 3 we would understand the correlation, and in lesson 4 we would cover the regression. Okay, lesson 3, lesson 4. Okay, so then we can start the lesson 4. Okay, okay, now if it is already done we can start from the regression. Okay, so meanwhile I can just recap what is correlation. So correlation basically measures the relationship between two variables. Okay, you can find the relationship between two variables, that means how the two variables are related, what kind of relationship they may have. It may be positive relationship, it may be negative relationship. Okay, and you can find the amount of relationship also. So the correlation, through correlation you would find only the linear relationship. You cannot find the non-linear relationship through correlation coefficient or through, you can say, covariance formula. Okay, so this is one, you can say, assumption that we would find only the linear relationship between the two variable. Okay, and we have the three measures. One is the covariance, then the correlation coefficient, and then the coefficient of determination. So covariance basically find the relationship, but it is not unit free, and its values can be anything. Okay, so therefore we have the another measure, which is the correlation coefficient, which is unit free, and its value is from -1 to +1. If you have +1, you can say you have perfect relationship. If you have -1, you can have negative perfect. And if you have zero value of R, then you can say you have no relationship between the two variables. Okay, that means if something is happening to one variable, x is increasing or decreasing, then y is not changing corresponding to that. That is the meaning of no relationship between the two variables. And if x is increasing, y is also increasing. If x is decreasing, y is also decreasing, then you have a positive relationship. And if you have vice versa, if x is increasing while y is decreasing, then you can say you have a negative relationship. There is a relationship, but it is negative. Okay, so we can find the relationship between the two variables with the help of statistical measures. It may be covariance, it may be correlation coefficient, it may be coefficient of determination. So you have, I hope you already done all these three. How would you find the correlation between the two variables? Okay, in the unit 3. Now unit 4 basically discuss the regression analysis between the two variable. Again, we will deal with only the two variables here, not more than two variable. Although you may have more than two variable, your demand may depend only on the price, or your demand may depend upon price, quality, advertisement budget. There may be many factors. Okay, so y may be function of x1, x2, x3, x4, but we are here considering only simple regression. That means y would be function of x only. So what do you mean by all these things? Okay, so simple, we have to deal with the simple linear regression, not the multiple linear regression, or you can say non-linear regression. Okay, your syllabus basically confine only to the simple linear regression where we have only two variable, one is x and other is y. Like if you have to find how height and weight are related. Okay, height and weight of human beings or of students of BBA or BMS. What is the relationship and how the regression is different from correlation? Anyone? If you have any idea how the regression is different from correlation? In unit 3 we have studied the correlation. You can find the relationship between the two variables. Now what is the regression and how it is different from correlation? So correlation is just gives you the linear relationship between the two variables, okay, through covariance or through correlation coefficient. But regression gives you the mathematical form. It gives you the formula. It gives you the relationship in mathematical form between the two variables of kind. That means you can find now the relationship between two variables like this way, ki y equal to ax plus b. So now you can find this a and b. This x may be your height, okay. X may be the height and y may be the weight. X may be the price, y may be the demand. Okay, till now you have to find the only r between x and y. You are saying 0.8. What do you mean by r? The correlation between height and weight is 0.8. It means there is a relationship, positive relationship between x and y, and good relationship. 0.8 is the good relationship, strong relationship you can say. But what kind of relationship you have? If I have to find the form, mathematical form of that relationship, how would you calculate that? Then you need this equation y equal to ax plus b. This is a linear equation you can say. You don't have non-linear. If it is x square, then it is non-linear. It becomes non-linear. We have to find the linear relationship only. Again we have to find the linear relationship between x and y. Okay. So that is the regression when you can actually determine the form of the relationship between two variables. Why? What helps this? This helps you to predict y value for given x. Okay. So you can, once you create a relationship, a mathematical relationship, then you can use this formula to predict your y value for given x. मान लीजिए ये हाइट एंड वेट है. अभी मेरी क्लास में मान लीजिए 10 स्टूडेंट्स हैं, उनके मेरे हाइट एंड वेट मुझे पता है. यूजिंग दिस डेटा ऑफ 10 स्टूडेंट्स आई वुड फाइंड अ रिलेशनशिप बिटवीन एक्स एंड वाई. वंस आई नो द रिलेशनशिप, नाउ आई कैन फाइंड कि अच्छा किसी का मान लीजिए वेट अगर या हाइट मान लीजिए 160 सेंटीमीटर, तो उसका वेट क्या होगा? व्हाट वुड बी द वेट, व्हाट वुड बी द वाई एट एक्स इक्वल टू 160 centimeter. Yes. So once you know the relationship, you can predict. So this prediction is basically regression. Okay. This is called the regression basically. So now you can see we have how you can come to this model. Okay. So we have to estimate this yi equal to alpha plus, instead of ab here it is taken alpha beta. This is just notation. Okay. So alpha is intercept and beta is the slope of the line, because it is equation of line, simple line. So alpha is the intercept and beta is your slope. So depending upon relationship, if you have positive relationship, the slope would be positive. If you have negative relationship, slope would be negative. Okay. Further, x is called y is called dependent variable. y क्या है? Dependent variable और x क्या है? Independent. Because y depends upon x. Okay. X is free. X can take any value while y would take value according to this equation, according to this formula, because y is equal to like 3x plus 2. So x can take any value. Suppose x is 1, then 3x plus 2 would be 5. If x is 2, y becomes 7 and so on. So once you know that regression line, regression equation, you can find any y for given x or vice versa. Okay. So this independent variable which is x, this is also known as explanatory variable. Dependent variable which is your y is also known as response variable. Okay. And you can easily find, this is the derivation which have been done here. So there are some assumptions of the model. Okay, how would you have calculated this regression line? So whenever you derive some model, there are some assumptions, notations, okay, and then you drive to that model. So assumptions are very important. Sometimes they may be asked. So assumptions are linearity. Already I told you, you can only find the linear relationship. Okay, that means other type of relationship you cannot find using this. There may be some relationship, but you cannot determine that one. Only you can find the linear relationship. If it is non-linear, then you can use this. Independence. That means all the error terms. Okay, all the error terms in your model, they are independent to each other. So error क्या होता है? What is error? If you see this model, यहाँ पे अगर आप देखेंगे, this your EI, what is this? This is called error. Now what do you mean by this? Suppose for any given bivariate data, x and y, suppose 10 observations are given to you. Okay, so for each y, you have some x value. मान लीजिए 160 हाइट पर वेट है 50 किलोग्राम. But if you calculate using this formula, then it may not come exactly 160. So there may be some error, you can say. So error for each observation. Okay. So these errors, you can say, they are independent. They are not dependent. Okay. Next assumption is normality. The error terms follows a normal distribution with mean 0 and constant variance. This we have to assume. Similarly, homoscedasticity, that means all the error terms have equal variance. Okay. So this is called homoscedasticity. Okay. So these four assumptions should met. Only then you can develop your linear regression model. So someone if asks you what are the assumptions for linear model, so these you should mention these. Okay. And then through least square method, we can find the value of this alpha and beta basically. We have to predict what is alpha and beta, because when I am saying you have to develop a regression model, you have to find this relationship between y, okay, a and b. So how would you calculate a and b? So for calculation of a and b, or for determination of a and b, you would use the least square method. Okay. So what is this? If you have some data, okay, then you can find, you with the help of that data you can find this value of a and b. Because you can find the error. If you have data, then you can find the error. Okay. So this y cap represents the predicted y for given x. Okay. There are two y basically. One is the actual y and other is the predicted y. If you predict through your formula or through your this linear line. That is called your predicted y. I can explain this through this, just a second. So you have to calculate the predicted y, and one is the actual y, and the difference between two is called the error. Okay, and what is your aim? Your aim is to minimize the error. Okay, you have to minimize the error. So how would you minimize that error? That I can just briefly tell you. Suppose you have this x and y. This is your bivariate data. Suppose this is 1, 2, 3, 4, 5. The corresponding is 10, 7, 6, okay, 9, 8. This is your x and y. Suppose you have only 5 observations. So here n is 5. You can easily find, if you need to find the correlation coefficient, you can easily find the correlation coefficient between these two variables. Okay. Now, how would you find the predicted y? Predicted y would be your, suppose you have some relationship, this 3x plus 2. So, according to this, when x would be 1, okay, y would be 5. If this is 2, then it would be 7. This 9, 11, 13. So this is the predicted y. If you have this type of relationship, right now I don't know what kind of relationship I would have. But suppose if you have relationship 3x plus 2, then you have predicted y. Now what is my aim? My aim is to reduce this gap. You can see now the error is, here you have 5 error, okay. Here 0, here you have minus 3, here minus 2, here you have minus 5. This is my error. Okay. So I want this error should be minimum total. If I add this total error, this should be minimum. Okay. So this is my motive to minimize the error, and for that what I need, I have to square the error, because sometimes error may be positive, negative. If you add, sometimes the total error may be 0. So therefore I square it. Before adding, I should square it, so that negative, positive all becomes positive. Summation of error square, or you can say summation of yi minus y cap का whole square. और y cap क्या है हमारा? I already know y cap is my yi minus a minus equal to a plus bx. Okay, so instead of y cap, okay, I can put the y cap value, because y cap क्या है मेरा? A plus bx. So y minus y cap would be y minus a minus bxi whole square, and you have to minimize this part. Okay, इसको minimize कैसे करेंगे? How would you minimize this? This is a function. Okay, this is a function of two variable xi and yi, like fxy, and if you have to minimize this, just differentiate x and with respect to x and y and equate to 0. By taking derivative and equating to 0, you get value of a and b. You get the value of, because this a and b are constants, so you get the value of a and b. So my motive was just to calculate a and b. Okay. So by taking derivative and equating it to 0 with respect to a and b, you can find value of a and b. So finally here you can see this is the b value, and this is, similarly you can find a, both you can find from this. Okay. So you can find or determine the relationship, you can say, with the help of least square formula. Okay, a and b under the assumptions, all these assumptions, and finally this relationship, or you can see this formula basically y b x. Okay, so for this b is basically called y v y x. What is this? This is called regression coefficient. Regression coefficient of y on x. This b is basically called regression coefficient of y on x, and this is related with the correlation coefficient. This is also equal to r x y. correlation coefficient between x and y multiplied by sigma y sigma x. This is the standard deviation of y, standard deviation of x. So this byx is also equal to this. You can derive from the formula which we have obtained. Okay. But in simple form, you can say byx is also equal to correlation coefficient into standard deviation of y divided by standard deviation of x. Okay. Further, we have some, you can say, property, or before property you have basically two lines of regression. We have always two lines of regression. One is y on x, जो अभी हमने कैलकुलेट करा ये y on x, and other can be the regression line of x on y. This depends upon you. You have to decide if you have two variable x and y. So which equation you need to find, x on y or y on x? Okay. So x on y would be, you can say, for this you have to find bxy. यहाँ पे आपने byx निकाला, here you have to find bxy, and bxy would be again rxy into sigma x upon sigma y. Not here you have sigma y upon sigma x, here you have sigma x upon sigma y. And if you multiply both bxy into byx, so you can see this sigma x would be cancelled out and you left with r square. So this is a relationship between the two regression coefficient. Correlation coefficient is geometric mean of regression coefficients, because r, you can say r is equal to bxy into byx का square root. So correlation coefficient is geometric mean of regression coefficient, or square of correlation coefficient is equal to multiple of regression coefficients. So there are two regression coefficient, one is y on x, another is x on y. Similarly, we have two equations of line, two regression lines. Okay, so first जो regression line है, one is the regression line of y on x and other is the x on y. So x on y on x would be the form of y minus y bar equal to byx into x minus x bar. This is the form of regression line of y on x. And second, this x on y would be x minus x bar equal to bxy y minus y bar. So these are the two regression lines. Okay, so whenever you have data, now you have to decide what which kind of equation you have to develop or you have to calculate, bxy or byx. Okay, the two regression equations would be differ, they may or may not be same. If you have perfect relationship, only then they would be same, otherwise they would not be the same. Okay, so these are the properties of these equations. You can see regression lines. Goel-Pearson coefficient is the geometric mean, as I already told you and explained to you. Okay, second is the two regression coefficient must be of same sign. Okay, that means both regression, either both would be positive or both would be negative. It is not like that one is positive, other is negative, and vice versa. Similarly, if one regression coefficient is greater than 1, then other would obviously less than 1. Because if you multiply both, it must be, because it is square of regression coefficient, and regression coefficient always lies between 0 to 1. Square of the regression coefficient 0 to 1. So you cannot have one negative and other is positive. Both would be of same sign. Further, regression coefficients are independent of change of origin but not scale. while if you remember the correlation coefficient is independent of change of origin as well as scale. Okay, so these are some very basic property. Now suppose you have this problem, you want to study the relationship between the sale of a certain electronic item and the advertisement budget. Okay, so you have the bivariate data of 15 different companies who are dealing with the similar product. 15 कंपनीज का हमारे पास डेटा है, यानी उनका बजट क्या था और कॉरस्पॉन्डिंग सेल क्या होगी. मान लीजिए एक कंपनी एक्स है, उसका बजट 10,000 था, तो उसकी सेल हुई 24,000. अगर बजट 12,000 था तो सेल हुई 25,000. सिमिलरली लास्ट में अगर बजट 13,000 था तो सेल हुई 24,000 अगेन. सो नाउ आई वांट टू फाइंड द relationship, or I want to find the regression line. Here you can also find the correlation coefficient also. If you find the correlation coefficient, you can easily calculate and you can find कि what kind of relationship between budget and sale. अगर budget बढ़ेगा तो क्या sale भी बढ़ेगी? तो you can find from R. Once you calculate, if R is positive, yes, you can say yes, there is a positive relationship between these two variables. But suppose you have to predict it. Okay, if you have to predict कि if the budget is 50,000, what would be the sales? वो तो नहीं है ना यहाँ पे. मैं कहता हूं अगर बजट मेरा 50,000 है तो सेल क्या होगी? That you can find with the help of regression line. तो उसके लिए आपको क्या करना पड़ेगा? You have to calculate, you have to determine the regression line. अब नाउ क्वेश्चन इज कौन सी निकाले हम, एक्स ऑन वाई है या वाई ऑन एक्स? तो दैट डिपेंड्स आपको क्या निकालना है. जैसे मैंने कहा इफ आई हैव टू फाइंड सेल कॉरेस्पॉन्डिंग टू गिवन बजट, तो नाउ द बजट वुड बी योर इंडिपेंडेंट वेरिएबल एंड यू हैव टू फाइंड सेल्स. सो सेल वुड डिपेंड अपॉन बजट, सो सेल वुड बी योर डिपेंडेंट. तो सेल क्या हो जाएगा मेरा वाई और बजट क्या हो जाएगा एक्स. अगर रिवर्स है, आपको गिवन क्या है सेल और आपको बजट निकालना है, तो सेल आपका क्या हो जाएगा फिर एक्स हो जाएगा. तो डिपेंडिंग अपॉन व्हाट यू नीड बेसिकली अकॉर्डिंगली यू हैव टू सिलेक्ट योर एक्स एंड वाई. अकॉर्डिंगली यू हैव टू सिलेक्ट योर डिपेंडेंट एंड इंडिपेंडेंट वेरिएबल. ओके, so let us here you represent budget by x and sales by y, you can see, and then you do the calculations as according to formula. Okay, you have to find the xy, x square, y square. Okay, and you put in this formula and you get b which is 1.14 and a is your 10.6. So you calculated a and b both. You need only these two things, a and b, because this formula is derived with the help of least square. So this guarantee that this line is best fit in your all these 10 points. जो आपको ये points दिए हैं, डेटा गिवन है, ये जो आपका 15 कंपनीज का डेटा है ना, if you plot on graph paper, एक पॉइंट इधर इधर ऐसे है, तो you fit a line basically, and that line is the best because you have minimized the errors. So therefore we use the least square. ऐसे नहीं है कि लाइन ये जो y इक्वल टू a प्लस बी एक्स आई है, a का फार्मूला है, b का फार्मूला है. जो फार्मूला आया है दैट इज थ्रू सम लॉजिक which is minimizing the errors. So that line is the best fit. उससे बेस्ट लाइन हो नहीं सकती. Therefore we call it regression line. So you calculated this a and b. Okay, and you can also show through this graph you can see. तो ये जो all the 12 points आपने ये प्लॉट किए, x को आपने बजट लिया है, y को आपने सेल्स लिया है. Okay, and you can see all the points and this line जो ये dotted line है, this is your regression line जो आपने फिट किया है. आप कहोगे सर लाइन तो बहुत कुछ हो सकती थी, मैं ऐसे कर सकता था, ऐसे ऐसे. There can be thousands of lines, infinite number of lines which you can fit in this given data. But the one which is minimizing the error, this is the best one. Okay, and you have find that one only. So you can see this intercept जो आपका, if x would be 0, अगर x 0 होगा तो क्या होगा, y equal to a क्या है आपका इंटरसेप्ट, यानी जो इंटरसेप्ट है मेरा कितना है 10.5. अगर आपका यहाँ पे x ये बजट 0 होगा तो ये इंटरसेप्ट यहाँ कहीं पे करेगा ना आगे जाके 10 पॉइंट समथिंग पे. इसको स्केलिंग हमने कम कर रखा है, 8 से स्टार्ट है, ये 10 से स्टार्ट है. अदरवाइज इफ यू स्टार्ट फ्रॉम 0 तो देन यू कैन सी दैट थिंग. ओके, एंड स्लोप इसका क्या है 1.13. ये स्लोप है, स्लोप इज पॉजिटिव, तो यू कैन इजीली सी दिस डिपिक्ट्स यू द पॉजिटिव रिलेशनशिप. अगर आप इसका कोरिलेशन कोएफिशिएंट भी निकालेंगे तो इट वुड कम अराउंड 0.7 0.8 समथिंग लाइक दैट. So correlation coefficient is different from regression coefficient. Regression coefficient आपका है 1.13 और ये कौन सा coefficient है, y on x. Okay. So this way you can depict. This is graphical interpretation, okay, of your regression line. So now if you see this last line, if the marketing manager wants to know the estimated sale for an budget of rupees 10.5 thousand, so you can easily obtain the sale is y, sale would be 1.14 into जो आपके x की वैल्यू x क्या है, बजट है 10.5 है, प्लस इंटरसेप्ट या कांस्टेंट जो है 10.6, so you get 22.57 thousand. So इतना सेल्स होगा. So ये this is the advantage, this is the your final our motive of regression line. Okay, once you develop a relationship, now you can predict, you can regress other variable. If one is given, you can find or estimate the other one. So this is widely used, you can say, everywhere. It has a lot of applications. Okay, regression. In analytics, everywhere you have to fit the regression models. This is simple linear regression because we are looking only the effect of on sales, we are looking only the effect of budget. आपने देखा यहाँ पे हम सिर्फ बजट देख रहे हैं इसमें. Okay, सेल मेरा क्या है, y dependent, sale is dependent on budget, but sale is not only dependent on budget, it may depend upon price also, it may depend upon quality also, it may depend upon the income of the persons who are buying, it may depend upon the location also, it depend upon the education level of the persons who are buying. So there are many factors on which sale may depend. So you can consider all these factors, then it could be multiple correlation. Okay, multiple, more than one variable, 2, 3, 4, 5, 6, 7, x1, x2, x3, x4. So that you can think of that. Okay. So after this, before going further, before going to standard error, I want to show you some example. For example, this there are two lines of regression. Now you can see, as I already told you, you always have two lines of regression. Okay. In that example, we have taken sale as y, but it may be possible you can take sale as x. You can say x sale is my independent variable and budget would depend upon sale. If your perspective is like that, then you have equation x on y. Okay. So if you have something like that problem, you have two regression equations, because you always have two types of regression equations. So you have to suppose find the mean, because the regression equations have one property, that mean of your two, you can say x and y, mean of x and y would pass through both lines. Okay, this is one property, that the mean of x and y would pass through both the lines of regression. Okay, so if you have to find the mean of x and y, then just solve these two equations and you can find the mean. Okay, So you can find 13 and 17 would be the mean. If you solve these two, 13 x bar would be 13 and y bar would be 17. Now if you have to find, suppose you have this type of problem, in a partial desktop lab record, only the following results are you can say legible. The variance of x you know, which is 9, and these are two regression equations you know. Now you have to find the mean of x and y, so you can just solve it and find the mean. Coefficient of correlation between x and y. How would you find the correlation coefficient between x and y? You have to find r. So how would you find r if you have given this information? Now r is equal to, as I already told you, it is the geometric mean of bxy and byx. Okay. How would you find bxy and byx? Anyone? Can you find the bxy and byx? Okay, if you have to find the your bxy or byx, then you have to assume, because you already have the two equations of regression. Okay, you both have the regression equations. So what? How would you find? You have to convert. I again have to do this up. So you have to assume कि first equation जो है आपकी, that is regression equation of y on x. तो second क्या हो जाएगी, x on y. So using that you have to find byx and bxy. I just tell you how you can do that, because problems may be of this type asked in the examination. Okay. So you have two equations. Let this 8x minus 10y plus 66 equal to 0. This be the equation of y on x. Okay, this is of y on x. So obviously next would be the x on y. Now how would you find the bxi? You already know the standard form is y minus y bar equal to byx x minus x bar. So you have to convert. That means the coefficient of x would be byx. So what is the coefficient of x? You have to convert this into y equal to, okay, y equal to what it would be. If you take 10y there, it becomes 8x plus 66 and divided by 10. So now this thing, this is your byx, which is 4 by 5. Okay. So this is my byx, because I assume, okay, let this. You can also assume the second one by on x. So let us see the first one. My byx is yes. Now from second equation, which is my 40x minus 18y equal to 214. This be the b equation of line x on y. ये कौन सी है x on y? So here you have to find the coefficient of x basically. Sorry, coefficient of y. So here you calculate x equal to, okay, x equal to क्या हो जाएगा आपका 18y plus 214 and divide by 40. So the coefficient of this is called bxy, and this bxy is 9 by 20. Now see, क्या ये दोनों सेम साइन है? यस. r क्या होगा? r would be square root of bxy into byx. So 4 by this 9 by 20 into 4 by 5. So this would be how much? 3 by 5, 0.6. So you can see it is coming 0.6. So how would you calculate the correlation coefficient if the two equations are given to you, two lines of regression? So you have to assume, okay, you have to assume first like y on x and second x on y. Your assumption may be wrong also. How would you come to know that your assumption is wrong? So you can see I have already done. First you have to find the mean. So solving 2 you can get the mean, okay, and then you have to find the regression coefficient bxy and byx, okay. Again we can down. So first I assume wrong assumption. You can see first I take a, let equation 1 is x on y, okay. Assuming equation 1 as x on y, so we find x. So यहाँ पे b x y क्या आया मेरा 1.2125 एंड सेकेंड इक्वेशन से b y x जो मेरा आएगा वो आ रहा है 2.22. So this is wrong. If you multiply both, the r would be more than 1, which is not possible. Okay. Hence you can see the both regression coefficient are 1 if you take the other assumption. अदरवाइज अगर आप लेते तो आपका रिग्रेशन कोफिशिएंट एक से ज्यादा आ रहे हैं दोनों, जो कि पॉसिबल नहीं है. अगर एक ज्यादा है तो दूसरा कम होना चाहिए था, बिकॉज द रिग्रेशन कोफिशिएंट कांट बी मोर देन 1. सो और अजम्पशन इज रॉन्ग एंड जो मैंने किया वो ठीक है, तो वो भी यहाँ पे किया हुआ है. यू कैन सी, ओके, एंड फाइनली योर आर इज कमिंग द 0.6. सो मतलब हो सकता था ना, जरूरी थोड़ी आप एक्स एंड वाई को पहला ले या आपने वाई ऑन एक्स लिया, आपने एक्स ऑन वाई लिया, इट कैन बी एनी वे. So you would find out that, okay, that error and you can correct yourself. Okay, so this way you can find the correlation coefficient between the two equation. And the third thing which you have to find, that is the standard deviation of y. Now you need to find standard deviation of y also. You have been given standard deviation of x. आपको r पता है, आपको फार्मूला पता है, किसी का भी आप फार्मूला ले लीजिए, बी वाई एक्स इक्वल टू आर इंटू सिग्मा एक्स सिग्मा वाई अपॉन सिग्मा एक्स. जस्ट पुट दिस एंड यू कैन कैलकुलेट द अनदर स्टैंडर्ड डेविएशन. तो ये लास्ट में आपको यू कैन सी, ओके, यू कैन फर्दर कैलकुलेट स्टैंडर्ड डेविएशन ऑफ वाई यूजिंग द फार्मूला ऑफ रिग्रेशन कोएफिशिएंट. इट्स वेरी सिंपल टू फाइंड दिस फार्मूला. Further you can see there are more examples also, okay. So this I already told you, okay. Yeah, suppose you, this is one another example and you have to find the regression line between x and y. So if you have to do all the calculation, you just do x square xy, okay. You find this a and b, okay, using this formula, and you can find the equation which is coming y equal to 1.357 plus 0.5x, okay. So here with this 1.357 is a intercept and 0.5 is your byx regression coefficient, okay. So these are regression equations which I am talking about, okay. Two equation, ऊपर आपका x on y है, नीचे y on x है, you can see, okay. And these are the regression coefficients, formulas of regression coefficient of bxy and bxy, okay. Another form of formulas, so you should remember all the form, bxy equal to r sigma x sigma y, or formula is sigma xy minus n x bar y bar, because if you have to calculate from the data, then you have to use the this detailed formula. And if you have been already given ki regression coefficient is this, standard deviation is this, then you can use the r sigma x sigma y to calculate your regression coefficients, okay. So you can see ये जो example है, simple सा example है, you have find both the lines of regression, y on x and x on y. So there are difference, you can see x on y and y on x. There are two lines of regression, okay, using this formula, and this is the calculation how you have obtained all these. Similarly, this is another example. You can see there are 9 salesperson, okay, of a company, and the data is related to intelligence test and the weekly sales. Okay, कि that मतलब you want to know the relationship between intelligence and sales basically, कि if some person is intelligent तो क्या उसकी सेल भी ज्यादा होती है या नहीं. Okay, it may not be necessary intelligent है वो आप, but sales may be less. Okay, so you want to find क्या क्या if there is any relationship, और अगर वो relationship है तो किस फॉर्म में है. Okay, so you can find again through this simple formulas. Okay, फर्दर जो मैं आपको बोल रहा था सिंपल फॉर्म में अगर आप देखेंगे, यूजुअली वी हैव क्वेश्चंस इन दिस फॉर्म. यू कैन सी कि इन द कोरिलेशन स्टडी द फॉलोइंग वैल्यूज आर ऑब्टेन्ड, द टू रिग्रेशन इक्वेशंस आर एसोसिएटेड विद द अबव वैल्यूज. आपको क्या है समराइज्ड वे में डेटा गिवन है. यू हैव बीन गिवन द मीन of both x and y, you have been given their standard deviation, and you have been given the correlation coefficient between x and y. 5 चीजें आपको दी है, दोनों के मीन, ओके, दोनों के स्टैंडर्ड डेविएशन एंड द कोरिलेशन बिटवीन x and y. नाउ फाइंड द रिग्रेशन इक्वेशंस. तो जो मैंने अभी बताया था इट्स वेरी सिंपल. वो फार्मूला आप यूज करेंगे पहली y ऑन x के लिए क्या, y माइनस y बार पता है आपको, इक्वल बी वाई एक्स क्या होगा, आर पता है आपको, सिग्मा वाई अपॉन सिग्मा एक्स. तो ऑल एवरीथिंग यू नो, यू जस्ट नीड टू पुट इन दैट फॉर्मूला वाई माइनस वाई बार आर सिग्मा वाई सिग्मा एक्स अपॉन सिग्मा एक्स इंटू एक्स माइनस एक्स बार. तो ये वाई ऑन एक्स आ गई इक्वेशन. एंड सिमिलरली एक्स ऑन वाई के लिए एक्स माइनस एक्स बार इक्वल टू आर इंटू बी एक्स अपॉन बी वाई सिग्मा एक्स अपॉन सिग्मा वाई and y minus y bar. So you can calculate the both lines of regression if you know these 5 things. So sometimes you may have the summarized data, sometimes you may need to calculate from the given sample data. तो वहां से फिर आपको मीन एक्चुअली निकालना पड़ेगा, वेरिएंस निकालना पड़ेगा, कोवेरिएंस निकालना पड़ेगा, then you can find this. Okay, so depending upon the marking and time you may have given these types of problems. So these are the properties, already we discussed these properties, okay, of the regression coefficient bxy and byx की जो properties है कि दोनों क्या होगा, या तो दोनों सेम साइन होंगे, अगर एक ज्यादा है तो एक कम होगा. and this is the geometric correlation coefficient is geometric mean of these both regression coefficient. Okay, arithmetic mean of regression coefficient is greater than correlation coefficient. अगर मीन लोगे बी एक्स वाई प्लस बी वाई एक्स डिवाइड बाई 2, तो इसकी जो वैल्यू आएगी दिस इज मोर देन द कोरिलेशन कोफिशिएंट. सो दीज आर सम प्रॉपर्टीज एंड यू कैन प्रूव देम आल्सो इफ यू वांट. ओके, एंड दिस इज द फॉर्मूलाज. सो ऑलरेडी वी डिस्कस दीज थिंग्स. ओके, फाइनली वी हैव द एरर पार्ट, स्टैंडर्ड एरर ऑफ एस्टिमेट. सो वंस यू नो द योर predicted y regression equation of y, you can easily find the error also. So you can see in this example, ये अगर आप एग्जाम्पल देंगे, सेम एग्जाम्पल, ये बजट एंड सेल था मेरे पास 15 ऑब्जर्वेशंस का. ये मेरा y कैप क्या, प्रिडिक्टेड y कहां से आया, जो मैंने अपनी इक्वेशन बनाई थी, दैट इज माय प्रिडिक्टेड y. नाउ यू कैन फाइंड एरर. ओके, सो दिस y माइनस y कैप, दिस गिव्स यू द एरर. इसका स्क्वायर कर दिया हमने, पहले हमने नॉर्मल निकाला फिर स्क्वायर कर दिया, तो यू गेट इट. ओके, एंड यू एड इट टोटल. सो द टोटल एरर यू कैन से SSE. ओके, स्टैंडर्ड एरर ऑफ एस्टिमेट, दिस वुड बी इक्वल टू 82.23. ये तो टोटल एरर का हुआ. इफ यू डिवाइड इट बाई you can say error of estimate, so you have to take the square root and divide by n minus 2. n is the total number of observations, 15 था, n minus 2 आप करेंगे तो you get 2.52. okay, so this is the standard error of estimate. This is the formula you can say if you want to know कितना error है आपके इक्वेशन में. आपकी इक्वेशन जो है दैट इज नॉट परफेक्ट, जो आपने बनाई है विच यू हैव डिटरमाइंड थ्रू लीस्ट स्क्वायर, दैट इज नॉट परफेक्ट, इट हैज सम प्रॉब्लम स्टिल, some variation which is unexplained. Okay, you cannot explain all the variation unless until you don't have a perfect relationship. Okay, so you have something left, you can say, therefore you have error. So which or further you can this see through the coefficient of determination. Coefficient of determination I already you have done in the unit 3 also. So that is the square of the correlation coefficient. Okay, square of the correlation coefficient, and its value is always 0 to 1. So you can find this because as I already told you, total variation, sum of squares of total variation, SST. Okay, total variation in y is this, and you can divide total variation into two parts. One is the standard error, which is explained by this regression SSR. Okay, which is explained by this sum of squares of regression, and second is the sum of squares due to error, which is unexplained, जो आपने explain नहीं कर पाई है आपकी equation. So you can divide total your variation into two parts. One is the regression part, other is the error part. So SST equal to SSR plus SSE, or you can say this R square is my SSR upon SST. R square क्या है? Which is explained. Okay, or 1 minus R square would be which is unexplained. So 1 minus R square would be SSE upon SST, which is unexplained part. So you can see for calculation of coefficient of determination, the square of deviations of y from y bar is already calculated. So SST हमारा 82 है, जबकि SST जो है आपका वो टोटल 290 है और SSR 208 है. यानी अभी भी हमारा जो ये रिग्रेशन मॉडल है, इट कैन एक्सप्लेन ओनली 72% अराउंड 0.717, यानी 72 variation, 72% variation is explained by my regression model. Still 28% is unexplained, and which you can say error in your model. So error here in this model is quite high, 28%. Okay, so I think we should stop here, although we have some assumptions, checking the assumptions here, but you can go through all these. Okay, and if you have some quick doubt you can ask me. Thank you. ये प्लीज अटेंडेंस साइन कर दीजिए प्लीज. थैंक यू. एक दे दीजिए किसी मेरे को.